now we're going to talk about sets of numbers. So we'll start with the first set of numbers that you probably learned. 1, 2, 3, and those are called the natural numbers. We didn't start you out with 0 or negative numbers. That was your first set. You were probably counting like blocks or something like that. Okay, those are called the natural numbers. They're also called the counting numbers. Okay, then somewhere around kindergarten, they introduced the concept of 0. And so it was all the natural numbers you already knew plus 0. And then these were called the whole numbers. So notice that every natural number is also a whole number. And then somewhere, at some point, they said, hey, we can have all the whole numbers and their opposites. So we can go in the other direction. We have these negative numbers then. Okay? And these are called the set of integers. Integers. Okay? So every whole number is also an integer. So every natural number is a whole number and it's also an integer. Okay. The next set of numbers we talk about are the rational numbers. Well, we can't list rational numbers. But they include all the integers. So every integer is a rational number. And it's anything you can put in the form of a over b, where a and b are integers. So that includes your fractions, 1/2 and 1/3. It includes your repeating decimals. And it also includes the terminating decimals. I should have said terminating first. So terminating decimals are like 0.25. Repeating decimals are like, 0.3333. It goes on and on and on. It includes all of those. Those are all rational numbers. So you might say, great, we're done. But we also have what are called irrational numbers. Okay, so here's a set of rational numbers, which includes all the integers, all the whole numbers, and the natural numbers. Then we have over here the set of irrational numbers. Now you can't be both a rational number and an irrational number. You're one or the other, okay? So irrational numbers include things like pi, square root of 7. Basically, they're decimals that go on and on and on, but they don't repeat and they don't stop, okay? So a lot of square roots. Those are just some examples. The square root of 2. And not every square root is irrational, but if they don't work out to be like an integer, then they're irrational. Okay. Then if you take all the rational numbers and all the irrational numbers, and you put them together, you get a big set called the real numbers. That's an R, sorry. Real numbers. And we do a lot with the real number set. We're able to do a lot of algebra with a set of real numbers. Okay, so now they want us to practice our knowledge of these sets of numbers. So natural numbers, remember those are the counting numbers, the ones you first learned. So no negatives, no decimals, no square root of 5, no pi, no 7.3. You know what? The square root of 81 is equivalent to 9, and that's a natural number. So we're going to say the square root of 81, which is really 9. Okay. I think they would write that, though, the square root of 81. Whole numbers. What whole numbers do we have? Well, we can't have any negative numbers. No decimals. That's not going to be pi. Nope. Just the square root of 81. I wonder if I left something in. Okay, integers. Okay, now the options are a little bit more now. We're going to include the whole numbers, right? The square root of 81. But we're also going to include, in this case, the negative 7. So that is also an integer. Those are the only two integers we have in that set. Rational numbers. Okay, the -7's okay. The -3/4, that's okay. It's a fraction. It can be negative. The 0.06 with the 6 repeating, that is rational. Repeating decimals are rational. But the square root of 5, no. You can't take the square root of 5 and get an integer. You can put it in a calculator and get a decimal approximation, but it won't be rational. Pi, irrational. Goes on and on and on. Doesn't repeat. Doesn't terminate. 7.3, though, that's rational. That's a terminating decimal. And then you have the square root of 81. Okay, so those are all rational numbers. Irrational numbers, well, anything that wasn't rational was irrational. So those two right there, the square root of 5 and pi. Now, we do have numbers that aren't real, but we're not going to talk about those today. Okay? So right now, our biggest set of numbers is the real numbers, and all of these numbers are real numbers. So we would just list the whole set. I was thinking, I didn't use any set notation, but I don't think they really want me to. They didn't ask for the sets. They just wanted the elements. So it wouldn't bother me if you put set notations on them. Okay, so that is it for that example. So kind of fun to try to do that.